In this video, I'm going to be doing a few more examples of implicit differentiation. So example 5 is find the slope of the tangent line to the ellipse 2x squared plus y squared equals 2 at the given point. So first of all, we want to realize that this is an implicit function. The x's and the y's are all mixed in together on the left-hand side. So we have to find the derivative implicitly. So remember, to find the slope of a tangent line, the slope of the tangent line is the derivative of the function at that particular point. So we have to find a derivative. So let's do that. So we're starting with 2x squared plus y squared equals 2. So this term, is in terms of x, so we simply take the derivative as we normally would using the power rule. Now the next term contains a y, which is the dependent variable, so we would write 2y to the first times y prime. And the derivative of 2 is 0. The next thing we want to do is solve this for y prime. So to do that, we're going to take 4x and subtract it to the other side. So we have 2y, y prime equals negative 4x, and then dividing by 2y, we have y prime is equal to negative 4x over 2y, which simplifies to negative 2x over y. So there is our derivative. So the slope of the tangent line is given by this expression, that function, that is the derivative. To find the actual slope, we substitute in the values of x and y. So we know that x is square root of 2 over 2, and that y is 1. So we will have negative 2 times the square root of 2 over 2 divided by y, which is 1. Well, these 2's cancel out, so we end up with negative square root of 2 over 1, which is simply negative square root of 2. So the slope of the tangent line is the negative square root of 2. In the next example, we want to take this just a step further, and we want to find the actual equation of the tangent line. So we've done problems like this before. The first step to finding the equation of the tangent line is to, number 1, find the slope. Find the slope. Well, again, that means finding the derivative. So we're going to take the derivative of the function 3x minus 2y equals x squared plus y. Notice that this is an implicit function, so we take the derivative implicitly. The derivative of 3x is 3. The derivative of negative 2y would be negative 2 times y prime. The derivative of x squared is 2x. The derivative of y would be 1 y prime. So that's my derivative, but we need to solve it for y prime. So let's get the terms with a y prime on the same side of the equal sign, all right, and get the terms that do not have a y on the same side, the opposite side. So I'm going to take negative 2y and bring it over there. So that's going to look something like, oh, and I'm going to take this and move it over here. So we're going to have 2y prime plus y prime on the right-hand side, and 3 minus 2x on the left-hand side. On the right-hand side, we can factor out the y prime, leaving me with 2 plus 1 is equal to 3 minus 2x. And now 2 plus 1 is just 3. So we have 3 times y prime. So 3 minus 2x is equal to 3y prime. Dividing both sides by 3, we have y prime is equal to 3 minus 2/3 divided by 3 is 1 minus 2/3 x. So the slope is 1 minus 2/3 x at x equals 1. So we have to evaluate this at 1. So minus 2/3 times 1. Well, 1 minus 2/3 is 1/3. So the slope of our line is 1/3. Well, that's the first thing that we do when finding the equation of a tangent line. The next thing that we do is we go to the point slope formula. Which we've used before, which is y minus y1 equals m times x minus x1. So we have our slope 1/3. So the 1/3 can be popped in here for that. We know what x is. It was 1, but we don't know what y is. So what we have to do is we have to go back to our original function and evaluate this function at 1. Okay, take the original function and let x be equal to 1. So we would have 3 times 1 minus 2y equals 1 squared plus y. So we have 3 minus 2y equals 1 plus y. Getting all the y's over on the same side and subtracting the 1 to the other side, we have 2 equals 3y, or y is equal to 2/3. So when x is equal to 1, y is equal to 2/3, giving us this ordered pair. So we can substitute these in. So y minus 2/3 is equal to 1/3 times x minus 1. Well, there's the equation of the tangent line, but let's clean it up a little bit. Y minus 2/3 equals 1/3 x minus 1/3. And then now let's add 2/3 to the other side. 1/3 x minus 1/3 plus 2/3. So I'm just taking this 2/3 and adding it to the other side. And I end up with y is equal to 1/3. Now a negative 2/3 plus 2/3 would be a plus 1/3. And I have an x right there. 1/3 x plus 1/3. So there is my equation of the tangent line written in slope-intercept form. All right.